Hello friends, welcome to our Genius Maths classes. Class PUC first year, subject mathematics, and chapter is sets. So myself Girish Bilkar. In the previous video, we have discussed about introduction of sets and representation of sets. Okay. In this video, we are going to discuss about the types of sets. Okay. So we know very well about sets. In previous chapter we have learned about sets. Set is a well defined collection of objects. Okay, and also we know about the representation of sets. One is the roster form, second one is set builder form, and third one is the Venn diagram. So these three things are very important to study the sets in next. Okay, so here we are going to discuss about the types of sets, and the list of types of sets are given here. So the first one is empty set, singleton set, finite and infinite set. Fourth one, equal set, universal set, subset. Seventh one, proper subset. Eighth one, superset. Ninth one, power set. Okay, let me discuss one by one here. The very first here, empty set. Okay, so let me discuss about the empty set. Okay, so first one, the empty set. A set which does not contain any elements is called empty set. A set which doesn't contain any element is called empty set, and it is denoted by phi. So it is also called as void set or the null set. So empty set can also be called as void set or null set. So the meaning of this empty set is the set does exist. The set does exist, but it doesn't contain any elements. It doesn't contain any elements. The best example for this is the home. The home is a set, and the home doesn't contain family members. The home without family members is the best example for null set, because the set home does exist, but the elements, the family members does not exist. This is the best example. So we can also give your best examples. Okay, and now in mathematics I can give some example. That is the set A. We are considering x, that x which is greater than 1 but less than 2, but x does belongs to natural numbers. The x belongs to natural numbers. So we just consider here x belongs to natural numbers, but our interval 1 and 2, our interval is 1 and 2, where there doesn't exist any x which belongs to natural numbers. So ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಿದ್ವಿ ಅಂದರೆ ಈ ಎಕ್ಸ್ ಅನ್ನೋದು 1 ಮತ್ತು 2ರ ನಡುವೆ ಇರುವುದರಿಂದ there are no natural numbers belongs to this set. There are no natural numbers belongs to this interval. That is why this set is empty. Okay, so we always have to think it. The null set, that is phi, is always contained in any other sets. The null set is always contained in any other set, and empty set is always a subset of other set. Empty set is always a subset of other sets. Just remember, empty set is always a subset of every other sets. Okay, and it also considered as an element of power set. It is also an element of power set. So this is about empty set, and next we are going to deal with the singleton set. So singleton set, a set which consisting of only one element. This set which consisting of only one element is called as singleton set. So for example, a equal to 1, b equal to 2, c equal to 3, these all three are the singleton sets. Here the singleton set always contain one element, so this is called a singleton set. So next, here we are going to discuss the finite and infinite sets. A finite and infinite sets. Okay, a set which is empty, or consists of definite number of elements is called a finite set. Otherwise it is called as infinite set. So here consider some elements which should be either it is empty, or it consists of definite number of elements. Andre ಈ ಸೆಟ್ ಐದರ್ ಎಂಟಿಯರ್ ಆಗಿರಬೇಕು ಆರ್ ಇಟ್ ಶುಡ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಸಮ್ ನಂಬರ್ಸ್ ಆರ್ ಸಮ್ ಫೈನೈಟ್ ನಂಬರ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್, ದೆನ್ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ as ಫೈನೈಟ್ ನಂಬರ್. ಅದರ್ವೈಸ್ ದಿಸ್ ಸೆಟ್ ಈಸ್ ಕಾಲ್ಡ್ as ಇಂಫೈನೈಟ್ ಸೆಟ್. ಇದಕ್ಕೆ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಪ್ಪ ಅಂದರೆ, let W be the, we consider W be the set of days of the weeks which is finite. Just consider, just W be the set of days of the week. So the week consists of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this is 7. So the week consists of 7 days, and therefore we always know that this is finite, which is finite. Okay, and consider another example. Let G be the points on a line. G be the points on a line, then G is infinite set. So we don't know the line contains how many points. It may be infinite. It is always infinite set, and therefore this set is always infinite. And remember that we cannot write all the elements of infinite set in a pair of braces in a roster form. So in infinite set we cannot write the elements of infinite set in a pair of braces in roster form. Always remember this. We cannot express the elements of infinite set in a braces, in pair of braces. That is the best example is set of real numbers. Okay, and now we have considered some example, and we have to some examples. Here the first example is, state which of the following pair of numbers are finite or infinite. In the below examples we have to write which of the elements, which of the sets are finite or infinite. The very first one is x such that x belongs to n and x minus 1 into x minus 2 equal to 0. The solution is, you just solve this equation. Okay, x minus 1 into x minus 2 which is equal to 0. That means x is equal to 1 and x is equal to 2. So here the elements are 1 and 2, which is finite because 1, 2 is easily written in a pair of braces in roster form. That is 1, 2, which is fine. And the consider the second example, x such that x belongs to n. Okay, and x is a prime. We know that our prime numbers are many, infinite. So set of natural numbers is infinite, and therefore this x belongs to natural numbers is always infinite. So the solution is the set of prime numbers is infinite, hence given set is infinite. Here we have discussed about the finite and infinite sets, and it is very important in our higher studies. So finite and infinite studies is very important, and we are going to discuss about equal sets. Okay, equal set means two sets are always equal when it consists of same number of elements. So here given two sets A and B, if every element of A is also the element of B and vice versa. So here the every element of A is also the element of B, and every element of B is also the element of A. And then we said the both elements are equal, that is A equal to B, and only the elements of A and elements of B are same. It should contain the same number of elements. It should contain the same elements, not same number of elements. It should contain the same elements. That is, for example, A equal to 1, 2, 3, and I am defining the B x such that x belongs to n and x is less than or equal to 3. Since x belongs to natural number, it should start from 1, and therefore it should be less than or equal to 3. Therefore B is 1, 2, 3. So here A equal to 1, 2, 3 and B equal to 1, 2, 3. It contains the same number of elements, that is why A is equal to B. So these kind of element sets are called as equal sets. Now equivalent set is different from equal sets. Equivalent means here given two sets A and B, the sets having the same number of elements but not same elements. Just remember, here the difference between equal set and equivalent set is, here sets must be same, but here the sets having a same number of elements, sets having a same number of elements but not same elements. That is why this is called equivalent set. This example is A equal to 1, 2, 3, 4, 5 and B equal to E, I, U. Here the number of elements in A is equal to 5 and the number of elements in B equal to 5, and that is why A is equivalent to B. So the just it is a difference of equal sets and equivalent set. Okay, So now the very important set in the set theory is subset. The very important is subset. Always remember the subsets plays very important role in a set theory. Okay, subset. Okay, a set A is said to be subset of B if every element of A is also the element of B. Means whatever the elements contained in A must also be the elements of B. Here ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಎದೊಳಗೆ ಇರ್ತಾವಲ್ಲ ಆ ಎಲಿಮೆಂಟ್ಸ್ ಬಿ ದೊಳಗೂ ಇರಬೇಕು. ಅಂಥ ಸೆಟ್ಗಳಿಗೆ ಮಾತ್ರ ಏನು ಕರಿತೀವಿ, ಸಬ್ಸೆಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ದೆನ್ ಎ ಈಸ್ ಅ ಸಬ್ಸೆಟ್ ಆಫ್ ಬಿ. In other words, we can say A is subset of B. So this symbol is subset. Okay, whenever A belongs to B, that implies A is also belongs to B. So ಯಾವ elements A ಗೆ ಸೇರಿರ್ತಾವಲ್ಲ ಆ elements B ಗೂ ಸೇರಿದ್ರೆ then we can call A is subset of B. That is, A is subset of B. If A belongs to A, that implies A belongs to B. This is the definition of subset. Remember, if A belongs to A, then A must be belongs to B. Whenever A is a subset of B. Whenever A is subset of B. So in this case, if A and B are same set, then we can write A is subset of B and B is subset of A. That implies A is equal to B. That is, A equal to B whenever A is subset of B and B is subset of A. This is very important. Okay. When we said two sets are equal, this is also a definition. Whenever A is subset of B and B is also subset of A. So this is the very important. The best example for subset is the set of rational numbers. The set of rational numbers is a subset of real numbers R. So here Q is a subset of R. And also natural number is a subset of R. Z is a subset of R. This is the best example. Okay, just remember or think. And in this we have a subtopics like subsets of real numbers. What are the subsets of real numbers? We have reminder here. Z is a set of integers. Okay, it is from minus infinity to plus infinity. Okay, Q is a set of rational numbers. It is in the form P by Q. Here P comma Q belongs to Z. Okay, and N is the set of natural numbers 1, 2, 3, so on up to infinity. And here Q dash is a irrational numbers. So this is also a set which is included in real number R. So N is a subset of Z, and where Z is a subset of rational numbers, and where all three are a subset of R, real numbers. So here R is the universal set, and all those Z, Q, N, Q dash are a subset of real number. So here the universal set is real number. And we also define the intervals on subsets of R. How to define the intervals on subset of R? Here A comma B belongs to R and A is less than B. Then the first one we are defining a closed interval. In the closed interval A comma B belongs to R, we can write X such that X is greater than A but less than or equal to B. X is greater than or equal to A but less than or equal to B. In this interval, the dot mark, okay, in the real line, the dot mark A and B are shown here, and it is a closure. Any X which belongs to this interval must be equal or less than X, less than A. Here less than B or equal. So this interval is closed interval. So X belongs to this interval. It may be equal to A or it may be equal to B. Any numbers which comes in the interval, this interval. Next, open interval. So in this open interval, A comma B belongs to R. X such that A is less than x less than b. If it follows this instruction, then it is called as open interval, and that means a must be lie inside this interval, not on the boundary, not on this boundary. So any x, it must be lies in this interval, not on the boundary here. That is why I kept it as open. So this is a open interval. And semi-closed interval, here a comma b belongs to R and ax such that a is less than x but x is less than or equal to b. Here x might be fall on the boundary, but here x cannot be fall on the boundary. That is why it is called a semi-closed interval. And semi-open interval, in this interval x is less than or equal to a is less than or equal to x, but x must be lies within the b. Here x must be lies within the b but not on the b. That is why it is a semi-open interval. So this is about intervals of subsets of R, and this is about subsets of real numbers, and we very clearly know about the subsets of R. Okay, next we are going to study about the power set. So the power set, it is a collection, of all subsets of A. So in the we have just studied the subsets. So here the power set is a collection of all the subsets of A, is called as the power set of A. So the collection of all the sets including A is called as a power set of A, and it is denoted by P of A. So in P of A, every element is a set. So you are considering 5, 1, 2. So here whatever you write in the power set, it is also the set. It is also the set. That is the example is, let A equal to 1, 2. Then P of A can be written as, we said that null set is always subset of every other set. Therefore 5 is a subset. And singleton set 1, singleton set 2, and A itself is the subset of itself. A is the subset of itself, and therefore this 5 singleton set 1, singleton set 2, and whole set, it is a subset. Therefore the number of elements in P of A is 4. That is nothing but a 2 square. If you consider A equal to 1, 2, 3, then the P of A is null set, singleton set 1, singleton set 2, singleton set 3, 1, 2, 1, 3, 2, 3, and A. So just consider, if you consider the set consisting of 3 elements, that is n of A equal to 3, then P of A null set, singleton set 1, singleton set 2, singleton set 3, 1, 2, 1, 3, 2, 3, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So n of P of A equal to 8. So we have seen here, if A contains 2 elements, the number of elements in power set are 4, that is 2 square. And here if you consider the set with 3 elements, that is n of A equal to 3, we are getting the number of elements in power set are 8, that is 2 to the power 3. So in general, you can write it as, if A is a set with n of A equal to n elements, the set consisting of n elements, then the number of elements in P of A is 2 to the power n elements. This is very important. Okay. Now we studied about universal set. So the basic set is called universal set. So every basic set is called a universal set. It is denoted by U or R, and its subset by the letters A, B, C, etc. The best example is R is a universal set, and Z, Q, N, Q dash are subsets of R. So this is the best example for universal set. Any basic set from which we can obtain subset is called as universal. Any set, any basic set, for example X, such that X less than or equal to 10 and X belongs to natural numbers. Okay, so that's 1, 2, 3, 4, 5 6 7 8 9 10. So this is the set A, and set B, set of even numbers less than 10. So set B is 2 4 6 8 10. So this is the set A, which is universal set, and the B is obtained from this set A, that is the set of even numbers less than 10, 2 4 6 8. So x 8 10, this is the subset. So this A is the basic set, and this is called as universal set. Okay, very important is proper set. In this proper set, A is subset of B, but A not equal to B. So any set which is a proper subset of some a set, but which is not equal to B, is called a proper subset. So this is all about the types of set we have discussed, and this is very important. Okay, so this concluded the types of set, so which is very important. Okay, thank you.